Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever today. We are going to take what we have learned about quadratics and solve some problems. So, let's get to it, shall we? Thank you, Coldplay. We'll be back to you in just a moment. Let's move forward. Right here, we have some verbiage with some strategies on how to solve what we're going to call word problems. If you want to pause and read that, that's great. I am not going to read it to you. I'm going to get right to it. Okay. A rectangle has length 3 centimeters longer than its width. Its area is 42 square centimeters. Find its width. Okay, so what we're going to do here is make a sketch of a rectangle. And I'll just say that the area is 42. And we know that area is equal to length times width. Okay, so we have to find its width. So whatever you're asked to find, let's let the variable equal that. I think it's already obvious because of the formula A equals LW. But I'll say let W equal the width. And I will label the rectangle accordingly. So this is the width, and we know that a rectangle has length 3 centimeters longer than its width. So this is the length, and that's equal to W plus 3. So I know that the area A is 42 equals the length W plus 3 times the width W. Now, if I had just L times W, then I couldn't solve it because I would have only one equation with two distinct variables. That's why I needed to call this W plus 3 instead of L. And now we have a fairly simple quadratic to solve. I'm going to subtract 42 here, plus 3W plus 42. And then I'm going to look, my delta, if you want to see if it's factorable, is b squared. So that's 9 minus 4 times 1 times 42. Wait a second. This is going to be minus 42. Sorry, I subtracted 42. So that's a negative. So that's 9 plus 4 times 42. 4 times 40 is 160 plus 8, 168. So that's going to be 177. That is not factorable. So I am going to use my handy dandy calculator, and I'm going to use the algebra function and polynomial tools and find the roots of a polynomial. It is of degree 2, and now I just need my coefficients. So where are we? A2 is 1. That's the coefficient of the squared term. A1 is 3, and A sub 0 is negative 42. So I got to remember that. 3, negative 42. Okay. And so it's all set for me. Isn't this the greatest thing ever? I hit enter, and there are my solutions. Let me go ahead and get those for us on here. Let's see. Okay. Bam. And there she is for us. Okay, so we can say that the width is approximately equal to 5.15 centimeters. We're always going to round to 3 significant figures unless otherwise indicated. So that makes the length approximately equal to 5.15 plus 3. So that would be 8.45 centimeters. I don't know why I did that because they just asked me for the width. Of course, we throw out the negative solution because length cannot be negative. So here's our solution right here. Wasn't that wonderful? One more question to go here. Is it possible to bend a 12 centimeter length of wire to form the perpendicular sides of a right angled triangle with area 20 centimeters? Okay, well, I'm going to draw a right triangle because that's the shape in question. Okay, and if from here all the way around to here, and I didn't draw a straight line, but if the legs of the triangle are equal to 12, and I let one leg, let x equal, I'll just say the short leg of the triangle, so I'll label it this. This is x, make this a right angle. Then this side must be 12 minus x. Think about it. If I take 12 minus x plus x, I get 12, which is the total length of the wire. Okay. Now the area, we are told, is equal to 20, and area of a triangle is equal to 1/2 the base times the height. So then I know that 20 is equal to 1/2 times 12 minus x times the height, x. So 20 is equal to 1/2. I'm going to go ahead and distribute the x first, and I'll get 12x minus x squared. So then 20 equals 1/2 times 12, so that's 6x. 1/2 times minus x squared is minus 1/2 x squared. And if I move everything to the left side, I get 1/2 x squared minus 6x plus 20 equals 0. So the question is it possible to do this? And we could spend some time trying to solve this. We could use the quadratic formula, or we could be smart about it. We're not looking for a specific solution. We're just wondering, is it possible? Well, if it's possible, I have to get one or two real solutions. How can I tell that? Delta must be greater than or equal to 0. It must be positive or equal to 0. If it's negative, well, we don't have any real solutions. So let's try b squared minus 4ac. So that would be b squared, negative 6 squared is 36, minus 4 times 1/2 times 20 is going to be 36 minus 4 times 1/2 is 2. 2 times 20 is 40. That's negative 4. That's a square root under our radical. Square root under radical. A negative number under the square root, which means it is not possible. There aren't any real solutions. All right, so that is all that I have for you today. I'm sure that you enjoyed it, and let's take it out with some more Coldplay, Life in Technicolor. A very awesome instrumental. And with that, I am